For problem 4, we have solve the integral of dx over the square root of 4x squared plus 1. For this problem, we can use trig substitution. If we can manipulate the denominator to look like x squared plus a squared, we can use trig substitution with x equals a tangent of theta. Now, if we factor out a 4 from inside the square root and remove it from the square root, we would have integral of 1 square root of 4 times square root of x squared plus 1/4 dx. This would be the same as 1 over 2 times the square root of x squared plus 1/4. And from here we can see that it's in the same format as this. So this is our x squared, and then this is our a squared. From here we can see that our a is 1/2. Therefore our x would equal 1/2 tangent of theta. And our dx would be 1/2 secant squared theta d theta. Now if we plug in an x and the dx for where we see in the integral, we will get the integral of 1/2 secant squared theta d theta over 2 times the square root of 1/4 tangent squared theta plus 1/4. From here, we can factor out a 1/4 from both of these variables. And we will get 1/2 secant squared theta d theta all over 2 times the square root of 1/4 times tangent squared theta plus 1. From here, we can use that identity that 1 plus tangent squared theta would be equal to secant squared theta. From here, we can see that we will get the integral of 1/2 secant squared theta d theta all over 2 times the square root of 1/4 times the square root of secant squared theta. Simplifying this further, we get the integral of 1/2 secant squared theta d theta over 2 times 1/2 times secant theta. These will cancel out, and this secant and one of these secants will cancel out, leaving us the integral of 1/2 secant theta d theta, which in this case we can just bring the 1/2 in front. Knowing the formula for the integral of secant theta, we would get 1/2 ln of secant theta plus tangent theta. We know that tangent theta is equal to x over a, which is x over 1/2. If we insert a triangle, we can say that this will be our x, this is our a, or 1/2, and using Pythagorean theorem, we can see that this will be the square root of 1/4 plus x squared. We also know that secant theta is equivalent to 1 over cosecant theta. Which in this case, our cosecant will be 1/2 over the square root of 1/4 plus x squared. Simplifying this, we will get 2 times the square root of 1/4 plus x squared. And our tangent simplifies to 2x from this. Then we can rewrite our integral dx over square root of 4x squared plus 1 as 1/2 ln of 2 times the square root of 1/4 plus x squared plus 2x plus our constant of integration, which we will get here. And what we did was substitute this for our secant on the bottom and our 2x for our tangent here. And that's our answer.